Here we have another problem type where we use similar triangles. So we're going to use the proportion idea to show slope of the line segment between A and C is the same slope as the line segment between D and F. So because this is a line, all along that line, the slope stays the same. Now we want to be able to show that the slope at these two parts of the line are the same. So what we're going to do is we're going to use our slope formula and the idea that triangle ABC is equal to triangle DEF. Well, what is equal? The slope is equal. So what we want to do is we want to use our slope formula. Our slope equals y2 minus y1 divided by x2 minus x1. We're going to take that idea and we're going to say that triangle ABC, the slope is equal to, for triangle DEF, the slope there. If we plug in the correct values and we calculate this out completely, we should have some number equals that same number, because all along that line there's the same slope. Well, in this problem on the common assessment, they don't actually solve all the way out to find out what that slope is. We just want to show that we can set up a problem so that one slope will be equal to the other slope. So let's take a look at this. So for ABC, let's set up a T-chart. X and Y. And DEF, let's do the same thing. Because we need to know what our Y's and our X's are that belong with each triangle. So here we go. So if we look at point 1, I like to use left to right. It's just the way we read. So point 1, the coordinates are -5, +5. Because the X value that point 1 is over is -5, and the Y value it's across from is +5. All right, so -5, comma 5, and then point 2, it's -3, comma 3. So there's point 1, there's point 2. Well, triangle DEF, there are also X's and Y's there. So let's take a look. So point 1, we have 1, -1. Point 2, 7, -7. So what all this does for us is now we know what our Y1 or Y2 is for each of these triangles, our X1 or X2. Here's how we tell. Here's the Y for point 2. It's 3. So we'll substitute that in. And we're going to subtract Y1 from that triangle. So there's Y1. So X2 minus X1. So we have -3 minus -5. Now we put this in parentheses. We put this -5 in parentheses because it looks kind of funny to have -3 minus -5 without the parentheses there, because you have two negative signs right next to each other. So mathematicians put a parenthesis around that -5 to show that it is indeed a -5. All right, and that's going to equal our Y2 from DEF. So it's negative 7 minus negative 1. And that's going to be divided by our x2, which is 7, minus 1. Well, we don't like those parentheses in there, but we could leave it like this, and if there are parentheses in the answers, A, B, C, or D, for this problem, it's okay to go ahead and leave them there. But if you take a look at the answer choices and you don't see any parentheses, this is how we get rid of the parentheses. So 3 minus 5, that stays the same. But the negative 3 minus a negative 5, that's really the same thing as negative 3 plus 5. Here we have negative 7 minus a negative 1, so it's negative 7 plus 1, 7 minus 1. So both this answer and the second answer, mathematically they're the same, but it's how they're expressed. So you have to take a look at the answers in the test and your answer choices to determine whether you can leave the problem this way or that way. Okay.